Hello and welcome dear learners to the next edition of Arithmetic Progression. In this video, we'll be discussing summation of n terms of an arithmetic progression or how to find out summation of any number of terms in an arithmetic progression. Now, comprehending summation in arithmetic progression actually reveals a symphony of numbers simultaneously bringing about harmony. So, let us see how we proceed to find out the summation and what are the simple formulae that we utilize to find out the summation of n terms in an arithmetic progression. Now, the first formula that we are going to talk about is Sn is equal to n by 2, 2a plus n minus 1 into d, where a is the first term, n is the number of terms, and d is the common difference. The second formula is n by 2 into a plus l, where a again is the first term and l is the last term, n is the number of terms. The third formula, of course, utilizes the summation values, but it is there to find out the value of any particular term. For example, if we have to find the value of the fifth term, then a5 will be s5 minus s4. That means if you know the summation of 5 terms, from that if you subtract the summation of 4 terms, you will get the fifth term. So let us see how we come to these formulae and how they were brought into existence. Supposing we take Sn is equal to the first one, n by 2, 2a plus n minus 1 into d. Now this can be written, summation of n terms can be written using the general term formula as a. Second term will be a plus d. The third term will be a plus 2d. And the nth term will be a plus n minus 1 into d. Now, the same sequence can be written in the reversed order as the first term a plus n minus 1 into d, the second term as a plus n minus 2 into d, and the last term as a over here. So now if we add these two sequences term-wise, we'll get here 2Sn is equal to 2a plus n minus 1 into d. I've added the first terms of both. Now the second terms of both also will give me 2a plus n minus 1 into d. And this will continue, and even the summation of the last terms of both the sequences will be 2a plus n minus 1 into d. So basically there are n terms of this same value. So we can write it as n into 2a plus n minus 1 into d. So Sn will be equal to n by 2 2a plus n minus 1 into t. This is the first formula. Now the second formula can be obtained by taking Sn is equal to and rewriting a as a plus n minus 1 into d. So this becomes, if we take this a plus n minus 1 into d as the last term, this becomes a plus n. So n by 2 a plus n. So from the first formula itself comes the second formula. Now let's take some simple questions initially to see how these formulae are applied. Find the sum of 20 terms of the AP of 1, 4, 7, 10. So here we need to find n is given as 20. The first term a is 1 and the common difference d is 3. So S20 utilizing the formula will be 20 by 2. 2a, that is 2 into 1 plus 20 minus 1, that is 19 into 3. I've just done the substitution in the formula. Sn is equal to n by 2, 2a plus n minus 1 into d. In this simple formula, I've done the substitution. So this comes as 10. 2 plus 57. So this becomes equal to 59 into 10, that is equal to 590. So this was a very simple question. Directly you have to substitute the value and simplify and you get the result as 590. Next question is find the sum of n natural numbers. Now natural numbers we know begin with 1. So this becomes 1 plus 2 plus 3 and it goes till n. So this we can take the help of the second formula and write it as n by 2. First term is 1 and the last term is n. So this becomes n into n plus 1 by 2. So sum of n natural numbers is n into n plus 1 by 2. Of course, you can get it with this formula also, but this was the shorter approach. Next question is find the sum of the first 25 terms of an AP whose nth term is defined by 2 minus 3n. So an is defined as 2 minus 3n. That means we can get the value of any particular term number by putting the value of the term number in place of n. So this becomes 2 minus 3, that is minus 1. A2 will be equal to 2 minus 6, that will be minus 4. So obviously D, which is equal to A2 minus A1, will be equal to minus 4 minus minus 1, that is equal to minus 3. So now we know D, we know A. We can find out the value of the first 25 terms, summation of 25 terms. So S25 will be 25 by 2, 2 into A, that is minus 1, plus 24 into minus 3. So this becomes equal to 25 by 2. This becomes minus 2 minus this becomes 72, and this becomes equal to 25 by 2 into minus 74. Or this can be written as 25 into minus 37. 2, 3, 6, and if you cancel it out, 2 ones 2, 2, 3, 6, you get your minus 37. Now if you multiply these to 25 into 7, of course, is 125. Sorry, it's equal to 175. So 5 over here, carry over 17. 25 3 is 125 plus 17 is 92. So you get minus 925. So sum of these 25 terms is minus 925. Now the negative sign is of course will be there because all the terms are negative. So summation will be negative. So nothing to worry about it. Next question is how many terms of the AP 63, 60, 57 must be taken so that the sum is 693? Explain the double answer. Now here in this question you are given the value of A as 63, D is coming as minus 3 and summation of n terms is 693. And we'll get two answers over here. Let's see how. So 693 taking the first formula is equal to n by 2. 2 into 63 plus n minus 1 into minus 3. So this becomes 693 into 2 is equal to n into this becomes 126 minus 3n plus 3. So this becomes 693 into 2 is equal to, this is equal to 129n minus 3n squared after opening the bracket and multiplying by n. So this can be rewritten as 3n squared minus 129n plus 693 into 2 is equal to 0. Now 3 is a common factor of all these three terms, so we can easily take it out, n squared. So we are left with 43n plus here we'll get 3, 2, 6, 9, 1 into 2 is equal to 0. So this becomes n squared minus 43n plus this becomes 462 is equal to 0. Now 462, if you bifurcate into prime factors and get the two values over here which whose sum will give us 43, they come to be 22 and 21. You can even use the formula for the quadratic formula and get the solutions for this equation. So here if I take 22 and 21, I'll get this as n squared minus 43n plus 462 is equal to 0. So I can write to that n squared minus 22n minus 21n plus 462 is equal to 0. 22 plus 21 will give us 43. 22 into 21 gives us 462. So take out n common, n minus 22 minus 21 common, n minus 22 is equal to 0. So we get here two factors, n minus 22 and n minus 21. This is equal to 0. So n is equal to 22 or 21. Now we are getting two answers. That means if we add 22 terms also, we'll get the same summation. 21 terms also, we'll get the same summation. But we have to justify this. So we'll find the value of A22. So A22 will be equal to A plus 21D, which is equal to 63 plus 21 into minus 3. So this becomes 63 minus 63, that is 0. So 22nd term is 0, so it does not make any difference if we have 22 terms or 21 terms. 0 will not create any difference. The next question is find the sum of n terms of the sum of n terms is given as 3n squared plus 4n. To find the second term and the nth term of the AP. So Sn is given as 3n squared plus 4n. So any term can be found out like an as Sn minus Sn minus 1. So if we take as this an value, it will be 3n squared plus 4n, and the term preceding this will be 3 into n minus 1 the whole square plus 4 into n minus 1. Wherever there is n, we'll put n minus 1. It is the term preceding the nth term. So this becomes 3n squared plus 4n minus 3 into, now if we open up the bracket here, we'll get n squared minus 2n plus 1, expanding using a minus b the whole square plus 4n minus 4. Now again, if we open up this bracket over here, the complete bracket with a minus sign outside, we'll get minus 3n squared, and this will become plus 6n and minus 3 plus 4, again minus 4n and plus 4. So now this negative 3n square, positive 3n square will get cancelled, 4n and negative 4n will get cancelled. So we are left with 6n plus 1. So the anth or the nth term is equal to this. Now the second term over here, a2 will be equal to 6 into 2 plus 1, that is equal to 13. You can even find d by finding a1. a1 will be 7, and so d will be equal to 13 minus 7, that is equal to 6. If the sum of the first 7 terms of an AP is 63 and the sum of its next 7 terms is 161, then find the 28th term of the AP. So here you have to be careful with the words that have been given. First 7 terms you have taken and the next 7 terms you have taken. So total altogether there are 7 plus 7, 14 terms over here. So S7 is given as 63. So 63 is equal to 7 by 2, 2a plus 60. And now we take the sum of 14 terms over here. So 14 term summation will be 161 plus 63. Because from here to here it is only 161. So right from the beginning it will be 161 plus 63, that is 4, and 224. So we can write 224 is equal to 14 by 2, 2a plus 13d. Now if we simplify this, we get here 7 nines. So 18 is equal to 2a plus 60. And here if we simplify, we get here 7. 7 3 is 21, 7 2 is 14, 32 is equal to 2a plus 13d. So now we are getting two equations over here. We'll write one equation below the other. 32 is equal to 2a plus 13d, and solve these two equations to get the value of a and d. So this will get cancelled. This will become minus 7d, and this will over here become minus 40. So d is equal to 2. Now once we get d as 2, we can find a also. So 2a is equal to 18 minus 60, that is 18 minus 12, that is equal to 6. So a is equal to 3. So the 28th term will be equal to a28 will be equal to a plus 70. So here we are getting a as 3 and d as 2. So we'll put the values over there. A as 3 and d as 2. So this becomes equal to 3 plus 14. That is equal to, sorry, this is 28 terms. So this will become a plus 27d. So 27 into 2, that is equal to 54. So this becomes 57. So a28 is equal to 57. Find the sum of 51 terms of an AP whose second term is 2 and the fourth term is 8. Now this is a very simple question. Directly, first of all, we have to take the help of the general formula. So second term can be written as a plus b. This is equal to 2. And the fourth term can be written as a plus 3d, and this is equal to a. So after framing these two equations, the important thing is to get the value of a and d, then the summation of any number of terms can be found out. So I'll write the second equation below the first one, and let's see what are the values of a and d. So minus 2d is equal to minus 6, so d is equal to 3. Now d is 3, so put the value of d in the first equation, so you get a is equal to 2 minus 3, that is minus 1. So we get the value of a as minus 1, d as 3. Sum of 51 terms is 51. This will be 51 by 2, 2 into minus 1 plus you get here 50 into d, that is 3. So this becomes 51 by 2 minus 2 and this becomes plus 150. So this is equal to 51 by 2 into 148. That is 2 sevens. This is 74. So 51 into 74. So if we multiply 74 by 51, we get here 7 4, 5 4 is 20, 7 5 35, 37. So the solution is 3774. So the summation of 51 terms is 3774. The first and the last terms of an AP are 7 and 49. If the sum of all its terms is 420, then find the common difference. So here the first term, that is A, is given as 7 and L is given as 49. And the sum of all its terms is 420. So here we will use the second formula, Sn is equal to n by 2 A plus L. So 420 is equal to n by 2. 7 plus 49, that is equal to 56. So 420 is equal to n by 2 into 56. So 2 2 is 4, 2 8 16. So n is equal to 420 by 28. So this is 14 2s, 14 3s, 30. So this becomes equal to 50. So number of terms are 50. And the last term is given as 49. So obviously 49 is the 15th term. So 49 with the help of the general term formula can be written as A plus 14D. Now A is 7 and D is not given. We have to find D. So 49 is equal to 7 plus 4D. This becomes an equation. So 42 is equal to 14D. So D is equal to 3. So common difference is equal to 3. So this is how we get the value of D from here. In an AP, the first term is 8, the nth term is 33 and the sum to first n terms is 123. Then find the number of terms and the common difference. The first term is 8, that means A is 8. An is given as 33. And the sum to the first n terms is given as 123. Then find the number of terms and the common difference. So we need to find n and d. N is not given and d also is not given. So first of all, let's take this an over here, that is 33. We take the help of the general formula A plus n minus 1 into d and put the values here. We get 33 is equal to 8 plus n minus 1 into d. So this becomes 25 is equal to n minus 1 into d. This is equation number 1. Now in this second case, we get over here 123 is the summation of n terms over here. So this becomes n by 2, 2 into A, that is 16, plus n minus 1 into D. So this becomes 123 is equal to n by 2, 16 plus, replace this n minus 1 into D by 25. So this becomes 16 plus 25. So 123 into 2 divided by 16 plus 25, that is 41, is equal to n. So 41 3s into 2. So n is equal to 6. There are 6 terms in this AP. Now find the common difference. So we put the value of n as 6 over here. We get 25 is equal to 5d. So d is equal to 5. So number of terms are 6 and the common difference is 5. The next question is find the sum of all integers from 1 to 500 which are multiples of 2 or 5. So here in this question we need to be careful about from this word from 1 to 500. That means 1 and 500 are inclusive if they satisfy the condition of the question. Which are multiples of 2 or 5. That is, they can be either multiples of 2 or multiples of 5 or they can be multiples of both. So this is the meaning of this word over here. So if we take the multiples of 2, the multiples of 2 will be 2, 4, 6, 8, 10. And it will go on like this till 500. 500 also has to be inclusive. Then the multiples of 5, of course, will be 5, 10, 15, but because we are already taking 10 in this particular sequence, in this sequence of multiples of 5, we'll start with 5, 15, 25 and go up till 495 only. You have to be careful. The terms that we have already put over here, because if we do not take 10 over here, it will cease to be an AP. So we have to take 10 in the first sequence over here. Now let us see how many terms are there in the first sequence. So we take the help of the general formula. So 500 is equal to 2 plus n minus 1 into d. 498 by d is equal to 2 is equal to n minus 1. So we get over here 249 is equal to n minus 1. So n is equal to 250. There are 250 terms here. In this case, how many terms are there? 495 is equal to 5 plus n minus 1 into 10. So this becomes 490 is equal to n minus 1 into 10. So this becomes 49 plus 1, that is 50, is equal to n. So here the number of terms are n 50 and here the number of terms are 250. So now to find out the number of summation of each sequence separately, we have 2, 4, 6. We have the first sequence as 2, 4, 6 and the second sequence as 5, 15 and so on. So now the summation of these 250 terms will be S250 will be equal to 250 by 2, 2 into 2 plus 249 into 2. So we can cancel out 2 from inside or outside anything. So this will become, if we want, we can keep 250 and eliminate 1, 2 from inside. We are left with 2 plus 249. That makes it 251. 250 into 251. So if we multiply this, we get here 2510 into 25. So that makes us 2500, 25 ones 25, carry over 2. 25 5 is 125 plus 2 is 127, carry over 12, 50, 60, 62. 62750. And the sum of 50 terms over here will be S50 will be equal to 50 by 2, 2 into 5 plus 49 into 10. So this becomes 50 by 2 into 10 plus 49, that is 500. So this becomes 25 and 25 into 500. That will give you 12500. So now this series gives us this summation and this one gives us this summation. So now we have to add these two. So 62750 plus 12500 will be equal to 0, 5, 12, 5, 7. 75250. So this is the final solution, 75250. This is the final solution. The next question is, find the sum of all integers from 1 to 500 which are multiples of 2 as well as 5. Here the words are 2 as well as 5. That means we have to take only those multiples which are multiples of 2 as well as 5 simultaneously. And from 1 to 500. So of course 1 cannot be taken. So the first term over here will be 10, the second term will be 20 and it will go up till 500. So we have to be careful with these words that are given in the question, 2 as well as 5, 2 or 5. So that has to be taken into consideration. So now this can be written as, now let's see how many terms are here. 500 is equal to 10 plus n minus 1 into 10. So this is 490 by 10 is equal to n minus 1. So n becomes equal to 50 after simplifying. This is 49 plus 1, that is 50. So S50 will be equal to n by 2, that is 50 by 2. 2 into 10, that is 20, plus 49 into 10, that is 490. So this becomes equal to 25 and this becomes equal to 510. So 0, 25 ones 25, carry over 125, 12750. So sum of these 50 terms is equal to 12750. The next question is, solve the equation 1 plus 4 plus 7 plus 10 plus x is equal to 287. So last term here is represented by x over here. So let's see if we use the second formula, 287 is equal to n by 2. First term is 1, the last term is x. So we get over here 287 is equal to n by 2 1 plus x. And x being the last term, if we use the general term formula, x is equal to a, that is 1, plus n minus 1 into d, that is 3. So this becomes 1 plus 3n minus 3. That makes it 3n minus 2. So this is the value of x in terms of n. So now here we put the value of x, 287 into 2 is equal to n, 1 plus 3n minus 2. So this becomes equal to n into 3n minus 1. So if we open up the bracket, 287 into 2 is equal to this. So 287 into 2, that will give us 14 to 16, 71, 574. 574 is equal to 3n squared minus n. And we can frame a quadratic, 3n squared minus n minus 574 is equal to 0. Now we need to find the factors of 574 into 3 so that the middle term is n. So if we take the last term or the 4 into 3, that is 12. So obviously if we take the product of 41 into 42, 41 into 42, 41 into 42, this will give us 574 into 3. This if you multiply and check it out, you will get 574 into 3. So 3n squared minus 42n plus 41n minus 574 is equal to 0. So you get here, take out 3n common, n minus 21 plus, 3 ones 3, n minus 14 plus 41 common, n minus 14. So you will get here is equal to 0. So n minus 14 and n plus 40, 3n plus 41 are the two factors is equal to 0. So n is either equal to 14 or n is equal to minus 41 by 3, which cannot be accepted because it's negative as well as a fraction. N has to be a whole number and positive always. So if n is 14, what is the value of x? X will be equal to 3 into 14 minus 2, that is 42 minus 2, that is equal to 40. Now finding out the factors is not a difficult task. You can break this up into prime factors and get the possible two terms which will give us the middle term as negative n and the product as 574 into 3. You can even do it with the help of the quadratic formula. So any method can be taken the help of. But remember, n cannot be negative or it cannot be a fraction. Now with that we come to the end of the questions in this particular video. Most of them were very easy, but one thing you must have noticed, all were of a different kind. They had different words. So all these are very important things. You need to check up on the words as well as the different type of questions and how you can solve them easily. So if you want to be very fast and quick in that, you need to practice a lot, do the similar type of questions so that you become adept in it. Kindly like, subscribe and share the channel as much as possible. Thank you for watching. And in the next video, we'll continue with more questions on arithmetic progression, mostly word problems, so that you understand the word problems also, how we can frame equations and we can get the solutions for arithmetic progression. Thank you for watching once again.